Let's get started. Thanks for coming to this session on request management. Just wait for PowerPoint to wake up. So my name is Spence Harbour. I'm based in Edinburgh in the UK. I work as a SharePoint architect, both with Microsoft and with their large enterprise customers. My contact details on the slide if you want to follow up with any questions after the sessions during this week. So as far as the topic of request management, what we'll talk about today is a brief overview of the feature at quite a high level in terms of what this is all about, why it might be useful to us. So we'll cover some sample scenarios or areas of perhaps quite common pain with the product where request management may help us. Then we'll look through, again, at a reasonably high level, the architecture of what Microsoft are providing for us with this feature, how it all hangs together. We'll talk through the configuration and management of the feature itself, and hopefully spend about half of the time of the, half an hour with a demonstration walkthrough, both in terms of its inherent behavior without us having to really do anything, but then a little bit more complex scenario, which is contrived. It's not a real-world example. It's not something you would actually do, but it's useful for showing all of the different elements of configuration that may be necessary. Then we'll finish with a little wrap-up and a few recommendations specific to this feature. So before we dive into the details, just for my benefit, how many of you in the room today have a SharePoint farm, really any version of SharePoint, doesn't really matter, of more than 2 web servers in the farm? Okay, so it's most of you. Good. Because this feature is really only relevant in that type of scenario. If it's a very small deployment where you've got a single web server, this feature isn't really going to do much for you at all, although it might be useful for like a small business server type scenario. Okay, so in terms of what this guy is all about, fundamentally it's some extra kind of intelligence within the SharePoint web server process that allows the system to understand more about the nature of incoming requests. But it's only the incoming HTTP requests that are managed by this feature. There are a number of other protocols that still are in play with SharePoint, unfortunately, that are sort of hanging around from previous versions, but this only applies to the incoming web requests. And it's predominantly focused towards incoming requests from end users, search engines, those kind of things. And the benefit of being able to use this information to make decisions is quite valuable to us, both in terms of a small on-premises deployment, but certainly for large-scale hosting organizations, gives them a lot of power to better scale the environments with more predictability. But it is quite a simple system. Fundamentally, it's all about routing the requests that come into the farm to the correct machines. So the first thing we're going to do in this system is decide if the farm that we're currently running on is the same farm that's going to respond to the request or process the request. How many of you here are running environments with more than one farm for the same user base? Okay, quite a few of you, interesting. So if you think about that type of environment where you might have multiple content farms, you may want to be able to distribute load across different farms, and this can help in that type of scenario, especially in hosting environments. And if the local farm, in fact, is the farm that's going to respond to the request, how should it deal with it, i.e. which web server, and so forth. And it's all based on a set of rules that we as administrators of the farm define, which allows us to do some interesting things. Like, first of all, we can immediately refuse certain types of requests that we might not like. That might be a denial of service type attack. It could be a particular client application which is putting a very heavy load on the servers that we might want to refuse or throttle. And then for the requests that we do like, send it to the appropriate server in the farm based on health characteristics and so on. And we are aware of the SharePoint health score, which you probably are familiar with from SharePoint 2010, which was introduced primarily to support web application throttling. But the problem with this particular feature, as useful as it is, it requires that the client application understands and respects this value. So some of the clients, things like OneNote, Outlook, etc., will not poll the server as often if the health score from the returned from the server is high. And those are a couple of examples of applications that are kind of good citizens. The vast majority of other client applications completely ignore the health score, so it's of no value to us in that respect. So this system, request management, inherently works alongside the health score to make the right call for us without us having to tell it to do so. So I'm now going to go through 4 slides which basically summarize the key usage scenarios for which this feature is intended to help. They're not all of them that might be applicable to on-premises deployments, but they're the most common. And they're probably all reasonably familiar scenarios for most of you if you are operating or managing farms. So the first one is about reliability and performance. In a situation where, say, we have 3 web servers and one of them is unhealthy, you don't want to continue to send incoming requests to that unhealthy server. First of all, the end users are going to get a bad experience in terms of page response time, but potentially timeouts. But it'll also mean that that server will never become healthy again, because whilst it's unhealthy, it's still being sort of pummeled with requests. So by default, without us having to do anything other than start the service instance of request management, the system is smart enough to route traffic to healthy servers and away from the unhealthy ones. And this is perhaps going to be, in the long haul, the most common usage of request management for on-premises farms. Very simple configuration and quite a big benefit at the end of the day. We can also use it from a reliability and performance perspective to make sure certain types of traffic go to the specific machines. And a couple of examples on the slides include we want to prioritize end user traffic over the traffic that might be coming from a search crawler or bot that's crawling our site. That's most common in internet scenarios, but it could also be true inside the organization. So depending on the type of client that's coming in, we can route to specific machines or prioritize them differently. Then we look at capacity, or really capacity management rather than capacity planning. And generally speaking, in our farms, if we have 3 web servers, we want them all to be kind of similar in terms of capacity, the hardware resources that they have, and so on. And that's a nice ideal, but the reality is it tends not to be that way. There's usually 1 or 2 that spend most of their time processing requests, but we want the ability to be able to equally distribute the load in the same way that a traditional load balancer might do. But we also want the idea of being able to create logical server groups, so a bundle of machines that are dedicated to a particular task. And we've had this concept in the product for a long time now with the idea of a dedicated crawl front end. So instead of pointing our search engine at the web servers that end users use, we point it at dedicated machines for the purposes of crawling and speed things up a little bit. And that's one example of where this feature can help us. Of course, we can do that type of thing using DNS or a host file, and that's how we've been doing it in the past for a long time. But this helps, especially in the larger environments, to be able to specify certain machines for certain types of incoming traffic. In the past, there's been lots of posters on TechNet that talk about the idea of server groups, but there's nothing in the product that allows us to actually implement them. And this is something that request management can do for us. And then with respect to scalability, this really is talking towards load balancers. In large-scale environments, whether they be for hosting situations or just a large-scale on-premises deployment, we're kind of tightly coupled with our load balancer of choice, both in terms of the complexity of managing it, but also how far it can scale before we need to buy another device, and these things are quite expensive. So in both of these kind of areas, request management can allow us to kind of avoid those problems in terms of scalability, but also make the load balancer concentrate on what it's good at, which is load balancing the network traffic, as opposed to doing smart things with the application, which are better handled by the application platform itself. If there are any manufacturers of these devices in the audience, they probably don't like me saying that, right? Because part of the reason they can sell their product is because of the smarts that it has. But unfortunately, the reality is we need to configure those smarts. It's not magic. And so request management can avoid both the scale problems, but also the complexity of configuration. Maybe the load balancer is managed by a different team to those that manage SharePoint, those kind of things. And then lastly, from an operational service perspective, which is perhaps the most interesting if we are SharePoint professionals, once the farm is in production and running, being able to understand what the root cause of a problem is and track down the errant server that's, the root cause of the problems is very valuable to us. So by using request management in a temporary way, when we hit a problem, we can move traffic to a known server that's good, and then continue our work to get to the bottom of the problem, hopefully resolve it, and then we bring that machine back in once everything is taken care of. So it's very useful when we're troubleshooting large problems where the usual scenario is the end users are complaining that something is quite slow, or we're not getting the throughput we need for things like user profiles and those kind of things. We can essentially make sure that that type of traffic is going to dedicated machines, so we can isolate and find the real problem quickly, more quickly than just by having to check each machine individually. Again, something that's more important the larger the farm becomes. Traditionally, these type of problems are very difficult, and most of the time is not spent on the fix. Most of the time is spent on identifying the particular component that's at fault by a 20 to 80% ratio there. So with those things in mind, those 4 buckets, if you like, are the reasons why you would consider this feature. Let's now talk a little bit more about how it works under the hood. Now, it's a very simple system, which is good, because simple is always good, and SharePoint, is certainly from an infrastructure perspective, has a very bad habit of making things more complicated than they need to be. But in this case, it's very simple. First thing is that it's available no matter what version of SharePoint 2013 you're running. So you can run it on SharePoint Foundation all the way to Enterprise. It's not configured for us by default. This is something that we need to turn on. And therefore, there's no kind of downside. There's no performance penalty or similar situation just by installing SharePoint 2013. Unlike another new feature, the distributed cache, which does have significant impact on the farm without us doing anything. And another thing that's very important to understand, especially for people who are running SharePoint farms on premises, is that the request manager capability, or request management, I should say, is scoped at the web application level. So if we configure it for one web application, it's only going to affect the content within that web app. And fundamentally, this impacts the way we design our logical architecture for the product if we wish to make use of this feature. And I'll talk a little bit more about that as we go through the rest of the material. So here's a little architecture diagram. We've got our SharePoint server, and within the SharePoint server, we have the web application service, what most people refer to as the web front end, but the product calls the SharePoint Foundation Web Application Service. That's just so that SharePoint books have more pages than necessary. And inside that process, we have the request manager, which is made up of 3 subcomponents, and they are kind of processed in this logical order. At the top, we have throttling and prioritization. That effectively allows the system to filter out requests that we want to refuse, but also prioritize certain types of requests if so configured. Then we have a routing layer, which is all about selecting the group of web servers which may respond, one of which may respond to the incoming request. and then finally the load balancer, which will dictate which individual server will respond to the request based on how we've configured the system. So it is fairly straightforward. The incoming request comes into the request manager. That then speaks to the service instance, which is a separate service, which is also the point at which we configure things. So there's really only two elements to this. The green box at the bottom is the thing that we interact with as an administrator. The blue box is really a black box, and that's how it should be thought of. It's not something that we can influence the behavior of. It works the way it works. We can configure some things, but we're doing that on the green box. And we can't plug in our own layer into the blue boxes on this screen. So we can't add anything else into it. So the first thing about this that's important to understand is that the request manager, the blue boxes in the previous slide, is the very first code that responds or is executed when HTTP requests come in. So there's no performance penalty of just turning this on, or there is a performance penalty, but it's so insignificant that it's very difficult to even measure that penalty. We're talking, very small amount of time. It's very fast, very well implemented. But it means it's doing it early in the pipeline before anything else like authentication, getting the layouts pages, processing any of the ASPX stuff, very early in the pipeline. And it's in process on the web server, which means our request management service, the green box on the previous slide, needs to run on the same machines. Okay, so wherever the web front-end service is running, the request management service should be running as well. And there is no point running the request management on our search server or our Excel calc server or any of those kind of roles, because they're not processing incoming requests in most cases. Then we have our web application itself. And this is really where the impact of this feature this feature impacts our way of designing our logical architecture. So in order for this to work, IIS obviously has to respond to the incoming requests. And just for my benefit, how many of you in your existing SharePoint environments have more than one web application and use host headers to configure those? Yeah, most of you, right? So the bottom line is this feature doesn't work in that deployment configuration. Because if you think about this, we have to take the incoming request, which might be www.contoso.com, and then map that request to an individual server. And if IIS is configured only with host headers, then those web applications or websites in IIS are not going to respond to anything other than the host header value. And this is a big change in SharePoint 2013, generally speaking, as it more closely represents the cloud service, Office 365. So we need this web application, which is going to initially process all of the incoming requests into the farm, which is a web application with no host header, which therefore will respond to every request. You may have heard, if you were in the previous session, Steve might have mentioned this as well. In some cases, to get the SharePoint app story working, we need a similar web application in order to be able to route the incoming requests for those funky app URLs to a SharePoint site collection. So that's very important. Also, we need to understand that the web application that initially responds might not be the web application where the destination of the content or the destination content resides. And that's really only true if we're using this across more than one farm. So let's talk a little bit more about the idea of host-based science. As I mentioned, this is really the most important thing in SharePoint 2013 that has changed considerably from previous versions and is mainly driven by the need to scale. The product traditionally has been very small intranet focus. right from 2001 all the way through the various versions, and also true of other Microsoft products, is very heavily favors short names rather than fully qualified names, and generally is not or was not originally architected for internet deployment. And we've had this feature called hostname site collections for a long time now, and it's slowly over the versions been improved, and it now allows us to have a significant amount of different customers residing in one single web application. In other words, gives us the ability to scale. And you'll find that many of the new capabilities, in fact, most of the areas of the product which have had significant investment, this example, the SharePoint apps example, and some others, are really focused very much on a deployment using hostname site collections. So in this example, we've got 3 site collections, contoso.com, fabricam.com, and tailspin.com, but they're all hosted within a single web application. We also need a root site collection, and this is just because of the way SharePoint works. If you don't have one of these, various things just stop working. And no, there isn't a list of all the things that stop working. There's some well-known ones and there's some less well-known ones. But the bottom line is you need this, not just to make sure things work, but also if you hit a support case and you phone Microsoft and you try and get product support, if you don't have one of these, they're going to tell you to go away and create it before they are able to help you further. So this is the world in which request management expects to work. If this is not your logical architecture, you're going to have problems configuring request management. So that's a pretty big sort of design consideration we need to bear in mind as we move forward. As far as this model is concerned, what we really should be saying, certainly if we worked for Microsoft, we would be very heavily sort of told to say, is this is the world you should be deploying for. But the problem is everybody's been doing it the other way. You all raised your hands earlier for a very long time. And that way works, right? There's nothing wrong with it. It works. And so it's not quite as, you can't just simply say, oh, well, we'll throw away what we've been doing, switch to this new model overnight. It's going to take a long time before the SharePoint world as a whole moves to this model. But if you want to scale to large numbers, this is really the only option. And this is how Office 365 is built. So in terms of request management specifically, get back to the main topic, we've got 2 modes of deployment, 2 options if you like. There are actually other options, but I'll come on to those in a second. The first one is integrated mode, and I talked a little bit about this earlier. This is where you have request management running on the web servers in your farm. This is going to be most appropriate for on-premises deployments. Reasonably small farms of less than 25 servers are going to use this model. Then we have the idea of dedicated mode, whereby you deploy SharePoint farm, a whole nother SharePoint farm, specifically for the purposes of doing request management. And this is really for large-scale hosters. It's generally not going to be very practical from a cost perspective, but also an operational perspective, to deploy a whole SharePoint farm, including SQL Server, backup and recovery, et cetera, just to do request routing. Okay? But in a large-scale hosting environment, this would be the right call because you would end up with less machines overall. Now, it is possible to kind of mix these up and have the idea of a hybrid deployment, which is having a separate tier which hosts the request management and distributed cache. You may have seen diagrams. Anybody at SharePoint conference may have seen some diagrams where there's now 4 tiers and a low latency tier at the top in between the users, as it were, and the web servers. Now, that idea will go away. Was a bad idea anyway, but nevertheless, it would have meant you needed to run the web server on both the low latency tier and the web tier. It just means more configuration, and it doesn't actually give us anything in terms of performance or scale either. So it's either one or the other. Don't try and sort of mix and match them. So this is what an integrated mode deployment looks like. It's fairly straightforward. we have our SharePoint farm, and there's 3 machines there in the middle, which are running the web server, and they will also run the request management component. And the request management component speaks to each of the machine, they all speak to each other to understand their status and so forth. But note, we also still have a load balancer here, right? So the request management is not replacing the load balancer. We still need a load balancer to distribute the incoming requests to one of those 3 machines. And then the other machines in the farm are whatever they might be for a particular deployment. And if we contrast this with the dedicated mode deployment, we've now got a request management farm over on the left-hand side, which is responsible for sending requests to other content farms over on the right-hand side. And you would only really need this, again, if you're in a very large-scale hosting environment. And we have some load balancers there as well. And because it's a large deployment, we have 3 of them. Because 3 is the new 2. If you're not familiar with the new world according to Microsoft from HA point of view, where you used to need 2 machines to be highly available, you now need 3, right? Because we need to apply Windows updates. So you need 3 instead of 2, which is good from a cost perspective, from the vendor's point of view. But anyway, that doesn't really matter. The point is, again, even if we've got this, we still need a load balancer of some description. So we can compare those 2 and sort of see where they fit. The main idea behind this is, if we have the integrated mode and we add another web server because we need more capacity, that means that's going to be doing request management as well. Whereas in this mode, we can scale these farms independently. So if you imagine your Office 365, you might have different types of farm here, and we don't have to necessarily change the request management farm to scale those other content farms independently. Obviously, the same is true for how much CPU and memory and so forth those machines have. We can also, in this type of world, the request management farm might be running SharePoint Foundation, but the other farms may be running standard enterprise. And the other difference is that in the integrated mode, we're tightly coupled with the configuration of IIS on the web servers, whereas in dedicated mode, we don't have that kind of dependency. But for the vast majority of customers, they're going to be using integrated mode. There's actually only 3 customer deployments that I'm aware of that are suitable for dedicated mode today, that I've heard about or worked with. Okay, so the load balancer, I've already mentioned this. We still need the load balancer. We still want to be able to distribute incoming requests at the network level to the web servers in the farm. What this does allow us to do is make the load balancer concentrate on what it's designed for, what it's engineered for in terms of performance and scale, and do the application stuff on the SharePoint machines. But we do have, depending on the load balancer we're using, we do have the ability to do some of the things that request management does on the load balancer. And we also have to understand different load balancers work in different ways, and how they understand the health of the servers in the farm is done differently across different vendors. And so we need to plan out the coexistence of these 2 things together. If you're using Microsoft's software network load balancing service, life is good, because in many respects, NLB is ignorant of the application layer. And so we can simply configure it as default, as we would do, and do all of the smarts in request management, and we don't really have too much to worry about. It's if we're using one of the other load balancers where it gets a little more complicated. And it's very important that we plan out how these 2 different things work together, because they're kind of doing similar things. And if we don't do this, we'll get unexpected behavior, or perhaps slightly confusing behavior. It's not working perhaps as we expected. And I'll show an example of that when we get to the demonstration. So in terms of our key components of request management, there's various elements that we will configure, And then rules is the brains of the system. And our rules are evaluated in a certain way. So our key components include our request targets. Now, request targets, sadly, in some of the documentation and in the APIs, are also called machine targets. It is a Microsoft product. They can't, they have to make one naming faux pas along the way, but they're the same thing. And this is basically a machine that is going to respond to a request, so a web server. And these guys have two properties. The first one is a static waiting, which is something we as administrators set. So if we wanted to, we could say server A is more powerful than server B, and therefore will have a higher weighting. Then there's the health weighting, which is not under our control, or not directly at least, and this is the SharePoint health score. And this is the other way around. So a high health score is bad, okay? So these two metrics are the opposite in that respect. Then we have machine pools, which is a collection of routing targets. So this is our server group, if you like. And we point our routing rules at the machine pools to allow the request management load balancer to figure out which individual routing target to send the request to. We have two types of rules. Throttling rules is basically the definition of the criteria to look at before refusing requests. So we don't associate these with anything, because if we match one of these rules, we're just going to kill the TCP connection at that point, and nothing further happens. Then we have our routing rules, which is the criteria to evaluate before we then send the request further down to the prioritization and load balancing components. And these ones we do point at machine pools or individual machines, depending on how large our farm is. We also have a thing called execution groups, which is useful for more complicated deployments, which is basically a collection of rules, or routing rules, I should say. So throttling rules aren't in execution groups, which allows us to determine the most important rules, or allows us to ensure that the evaluation precedence takes place, that we want takes place. And we have 3 of these. Imaginatively named 0, 1, and 2. We can't add another one. We can't, have 5. There's only those 3 available. Again, in most, on-premises deployments, assuming you're following all of the general best guidance out there for this feature, you would probably only ever need 2. 3 is there kind of as belt and braces in case you had a really complex requirement. Then we have a rule criteria object, which is basically the information to evaluate based on common HTTP properties to make a decision whether we want to send it to a given server or whether we want to throttle the request. So the properties that we can interrogate, if you like, or check are listed here: URL, URL referrer, user agent, host, SOAP action, custom header, etc. They should all be reasonably familiar to you. These are standard HTTP request properties. Every request has at least the first 4, or sorry, the first 6. The other 2 are useful when working with more advanced client applications. And the custom header one gives us ultimate sort of extensibility. If we are, let's say we're a vendor, a new SharePoint vendor, we've come up with a wonderful idea to build a rich client application that works with SharePoint. We could use one of those to integrate in with this feature. Now, that hasn't happened yet, and it's probably not that likely, but it's the way that Microsoft can basically say this feature is extensible. And then we will match those properties using one of these 4 operators, or really match methods. The first 3 operators there starts with, ends with, and equals. Should be fairly straightforward. And they are ordered in kind of the preference in terms of performance that you would use. Starts with is going to be a lot quicker than ends with, and certainly quicker than a regular expression. But again, regular expression gives us ultimate flexibility. Most of the things that we're going to do with this system, we can accomplish with starts with, ends with, or equals. But in some cases, regular expressions will be useful to us. there is a performance penalty of using them if the regular expression is badly authored. So we evaluate these rules via execution groups. The very first thing we'll do is we'll look to the throttling rules, and if we match a throttling rule, then the request is refused, we kill the connection. If we don't match any, we'll then go ahead and evaluate the routing rules in execution group 1. If we match in here, we'll route to the appropriate machine target, or routing target, I should say. If we don't match, we go on to execution group 1, and then we'll go on to execution group 2. Now, the important point here is at the very bottom, really. If we don't match any requests all the way through in all these 4 buckets, then the request will be sent to any available machine. So we don't need any special configuration for rules that don't match any, requests that don't match any rules. So we kind of fall through to the bottom and then continue on as you would expect. And that's a big change from the pre-release of the software that's worth pointing out. So a little diagram of this. This is a ridiculous scenario where we have 8 servers. But anyway, ignoring that for the moment, we have some throttling rules, 3 execution groups associated with machine pools. So in this example, we're running through that precedence, and we match routing rule 2. What that means is that at this stage, we'll evaluate all of the rules in execution group 0, so rule 1, 2, and 3. But the rules that are in execution group 1 and execution group 2 will not be evaluated. So as soon as there is a match, we ignore the following groups. And this is important because it means we need to keep or place our most important rules in that execution group 0 to ensure that they are evaluated. Because otherwise you might have another rule get matched and it will ignore the following execution groups. Oh, that's what I just said. And again, remember that if no rules are matched, then we route the request to any available target. And so if we want to do something like for a certain period of time, only go to servers 1, 2, and 3 out of a 6-server farm, for example, you create a rule with no criteria, in other words, a catch-all rule, and then you associate that with the server 4, 5, and 6 to enable that type of situation. In terms of configuration, we can do this by going into the request management configuration page in Central Admin. Unfortunately, this doesn't exist. They couldn't be bothered with that. It's all Windows PowerShell. And that sounds okay, and it's not too big of a deal if you're comfortable with PowerShell. The problem is we need to also think about how we maintain the system over the life cycle of the farm. So if you don't have robust, well understood scripts for this, you can get into a situation where it's very easy to misconfigure the rules and those kind of things. So it's very important that you think about how you're going to manage this longer term for the life cycle of the farm. Perhaps that's thinking about how the end customer is going to do that. It would be quite easy to build a management UI for this, actually. A few of us have kind of messed around with that for the purposes of demonstrating the feature, but we don't have it out of the box. So there's some key commandlets, and I don't want to spend too long on this because I'm going to show you these in the demonstration. And so I don't have examples on the slides like I used to here. The main one is SP request management settings. This is really the core parent of configuration, and we will use this later for all the other commandlets by piping it into their execution. And so this is the big daddy, if you like, the core configuration component. And then we have commandlets for managing routing machines, machine pools and their individual targets. The individual machines themselves are dealt with by SP routing machine info, and there you can see the naming confusion. Okay, that's a routing target, not a machine target. But marketing changed the name after the guys had written the code, so no going back there. Then we have our rule criteria and the two individual types of rules. So the first one is really just a definition of which HTTP property we're interested in, what the match type is, and what the string value we want to compare it to is. And then we have two sets of commandlets for creating, deleting, and so on, the individual throttling and routing rules. So it's fairly simple. There's really only six kind of families, if you like, of commandlets to work with. In terms of monitoring and diagnostics, once we've set it up, how do we verify and monitor that it's working as expected? How do we become alerted of problems? It's the usual suspects here. The SharePoint ULS logs includes now a category of request management. We have our IIS log files, which will always be useful to us. This will actually tell us more about the underlying infrastructure behind the scenes. And then we have some Windows performance counters, which will help us as well if we're using things like Operations Manager or Tivoli to look after the farm. Okay, so I've got an example scenario, and then I'm going to try and walk through a demonstration which shows all of the key configuration aspects of the system. So it's a contrived example. Again, you wouldn't do this in the real world. I made this up purely for the purposes of showing this feature. So I've got a single SharePoint farm. That means I'm running request management in integrated mode. I've got 3 SharePoint web servers, and I'm using the Big IP Local Traffic Manager product from F5 Networks as my load balancer. And I have that guy configured using the SharePoint application template that F5 ships, so it's in the default configuration for all intents and purposes. And then I have a single web application which hosts 3 site collections: Contoso, Fabricam, and AdventureWorks. And then I've made up some business requirements. I don't want requests from unhealthy servers to be dealt with by the unhealthy server. So in the case where one machine is unhealthy, I want the other 2 to take over. And I want that to be automatic with no impact to end users. I don't like OneNote. For whatever reason, we've decided that OneNote is evil and should be refused. So anything that's coming in from OneNote, we will refuse that connection. Then for requests for PDF files, should be served by SPO1 and SPO2, regardless of which site collection they live in. Then for the AdventureWorks and Fabricam site collections, I want them to be served by the same 2 machines. But Contoso are special, so they have their own web server, okay? And the reason for including Contoso in this demonstration is my PDFs actually live in the Contoso site collection. So if I configure my rules in the correct execution groups, then the PDF is going to be served by SP1 or SPO2 because that guy has higher precedence than the Contoso site collection rule. Now, obviously, you wouldn't do that kind of thing in the real world, but it is useful to show the execution group management. So this is my logical architecture. I've basically taken those requirements, mapped them to the elements of the system. I'm going to have a single throttling rule at the top, which is denying the OneNote client application. Then I have, in execution group 0, my most important rule, which is the one for PDF files. I know that might be a little bit difficult to see towards the back there. So for the PDF files, I'm going to serve those from the primary machine pool, which includes SP1 and SP2. I'm going to do the same thing in execution group 1 for my Fabricam and AdventureWorks, going to these machines. And then my rule for Contoso is going to be served by SP3, which is in the Contoso machine pool. You might be able to see down the bottom here that SP2 has a static weight of 9, and the other 2 machines have a static weight of 1. When this is configured, what this should mean, fingers crossed, is that SP2 will respond to most requests because it has a higher weighting. Okay, so let's try and take a look at these things on the demo machine. And we're going to run a bit short on time, I would imagine, but we'll try our best to get through this stuff. So hopefully we can see this. So here's my demo environment. It's very straightforward. I need to wake up this guy. I've been talking too long. So I've also got a client machine here, a Windows 8 machine, which is simply, I'm just going to use as my demonstration client. Just give me a second to log in here. And so you can see I have an AdventureWorks site collection, Contoso, Fabricam. They're all hosted on a single web application, which is running on my SharePoint machine. Here it is, SharePoint hosting. It's not using a host header. And I have the site collections under that guy. Here they are. And there's the root site collection as well at the top. And I've configured the load balancer to do what might be termed true load balancing. In other words, the load is being equally distributed across those 3 machines. So if we go into the management user interface for local traffic manager, you can see here I have a pool of servers called SharePoint pool, and we've got a total of 6 connections here at the moment. I should really have gone and got some more traffic. Let's do that quickly. Let's kill these. And if we come back over here, you see my individual nodes, 10.0.0.7.0.8 and 0.9, are all actually handling some traffic. So this guy's got 2 current connections. SPO2 has 2 connections. SPO3 has 2 connections. So just to prove that this is set up and it's distributing the load across each of the 3 machines. And the only other important point here is that within Contoso is hosting a couple of PDFs down the bottom here. And that's all there is to it. So before I turn on request management, let's have a look at what happens if one of my machines is unhealthy. So what I've done ahead of time here is I've created a HTTP throttling monitor for the processor. And what this means is, the way I've deliberately configured this is a low number there, low buckets at the bottom, 20 and 30. So if my CPU is being used on a machine, it's going to throttle the requests. So I've got a little application that I'm going to use to test this. And this is always fun doing a live demo here using this tool. What I'm going to do is request this application over here on the left-hand side, simply just keeps pinging the web server effectively, keeps trying to do a HTTP GET, and the red line is the CPU on the machine, and also the green line is the current health score. And we shouldn't see much green line at the moment because the health score is 0, and you can see that down the bottom here. So we do have a green line, it's just difficult to see at the bottom. I've got another application which is much more fun, which I'm going to use to stress out this web server. So this is SPO1 that I'm working with. So basically what I'm doing is I'm just punting a rather large file to the file system of the machine, and I'm initiating that with many threads. And so in a few moments, you see the red line has already kind of peaked up there a little bit, and you can see my CPU monitor down the bottom as well. So this machine is getting hammered at the moment. And you can see that the health score briefly, if you were paying attention, flicked to 5, and has now vanished. And the reason it's vanished is because the guy that wrote this app on the right made a little tiny mistake there. But you can see the green spike on the diagram is that this machine is now unhealthy. So let's go back to the client machine. My laptop seems a bit unhealthy all of a sudden. Oh, that's the wrong machine, that's why. I want to go there. So we go back to the client machine, close all of these guys. Open up this again. AdventureWorks. the server's too busy, basically. It's being throttled. But the load balancer doesn't know about that, right? As far as the load balancer is concerned, the web application is up and running. It's responding to HTTP requests. So the load balancer is ignorant of the health score and is just going to continue to send requests to that machine. These two work, because remember, I'm doing equal distribution here. I've got 3 different sets of requests, so they're all being served by one machine, and only one of them has a bad health score. So that's the behavior out of the box, whether you're using the big IP device, whether you're using Microsoft's network load balancing, whether you're using Cisco, et cetera, et cetera, et cetera. You have to tell those tools, those load balancers, to do something based on that health score if you don't want that screen to appear. And the other amusing thing about this screen is you note that it's got the old SharePoint 2010, SharePoint 2007 user interface. So they obviously, they never had a busy server when they were testing. Anyway, and you have the always useful GUID there. For whatever reason, you might need that. So, that's not what we want. Let's go ahead and fix that. I'm going to stop this because otherwise it's just going to completely kill the demonstration. So I have another PowerShell script over here, which is basically all of the configuration for request management. Now, what I'll do is I'll start this and then talk through it. It takes a few moments to run. Basically, all I'm doing here is I'm looping through all of the machines in the farm, and if my server is running the web application service, I'm going to start request management. So it looks quite complicated, but really all I'm doing is starting a service instance. I've just built these functions to kind of help out. I can run these functions on any farm, anywhere, and wherever the web service is running, it's going to start request management for me. And I could change these strings if I wanted to do other things with it as well. But really all I'm doing is starting the service instance for request management. And it'll take a few minutes to provision these guys on the other 2 servers. That's the wrong page. So you can see it started on 1, it started on 2, we've just got one more to do. Always starts being slow when you need it to hurry up. There we go, so we're finished now. So that's all I've done. Basically all I've done, I could have done this in the UI as well. I could have just gone into services on server, selected the right server, started the request management service. So if we come back over to the client here now obviously I stopped that little stress application, so everything should be working as expected. And you can see that I can see all of the individual site collections, no problem at all. Let's go ahead and run the stress application again. Same values as before, so we're doing exactly the same thing that we did in the previous example. Just wait for the CPU to show up. Okay, and I'll start it. Now we have to wait a few moments before it kind of updates itself. So there's our red line peaked towards kind of 60, 70%. And we do need to leave it until it's sort of got a few more lines across. But note the health score is still 0. And the reason the health score is still 0 is because request management is intercepting the request to the unhealthy server, sending it to a healthy server, and so that guy's responding with the health score of 0, which means good. And if I flip back to my client machine, hopefully this will work. And you can see that it should be AdventureWorks that fails, but this one's now working. But SP1 is not responding to any requests. It's all being done by SPO2 and SPO3. Let's go to our dashboard here. And select the first node. We'll see a couple of requests, which was the initial ones previously. There you go, see, 2 and 7. It was 2 and 6 before, so it's quite good. If we go to 8, which is SPO2, that's 2 and 6 as expected, and we should see the same again for SPO3. So by simply just turning on the request management service, we've dealt with that health problem on one machine without having to do anything else. And we also didn't have to do anything on the load balancer. No additional configuration. If I go to my web server here, I stop this because otherwise it just uses up resources. Here's ULS viewer. I'm going to open up the ULS on this machine. And I can filter this to request management just to clean it up a little bit and focus on what we're interested in. Oops. And you can see a bunch of traffic happening in here. And this is just the various call and response between the different servers in the farm. But the one that's highlighted, this guy here as well, mapping URI from this address to this address. This is the load balancer, right, the F5, pinging the individual server. Now, 10.0.0.7 is SPO1, okay? The idea is the load balancer is smart, so it does a HTTP GET, and depending on the response, you know, it could mark it as unhealthy, et cetera, et cetera. But because request management's turned on, it's actually routing the request to SPO3, which is the machine that's responding. So that's not what you want, right? Because you want the load balancer to be saying, to understand what the health of SPO1 is. And that's, you know, underlining my point about needing to plan the coexistence of these two things together. Remember, the load balancer companies built their intelligence before this feature existed. Now this feature existed and sort of is in the middle between the two of them, changing things up. Again, if you're using Microsoft NLB, this is a non-issue. You won't even see this incoming traffic because that's not how NLB works. NLB is a network load balancer, not an application-aware load balancer. And we're also doing other things, understanding the throttling, whether throttling's enabled, how many target machines we have, and so on. What I'll do quickly, we've got 2 minutes roughly, so I'm going to run the rest of the script, and we'll just see a few other things, like the denial of the OneNote files and the PDF, or the routing for the PDFs. So I haven't, you know, the rest of this script is basically creating my machine pools, execution groups, and routing rules. And the script is all on my website, so that's not an issue if you want to get hold of it. Or see more information about the individual settings. So what I've done here is I've created a bunch of routing rules and a throttling rule, a couple of machine pools, and so forth. And if we now go ahead and test this, I can load up the OneNote client application, and I can try and open one of those site collections. Unfortunately, in OneNote 2013, to open something on the internet, you have to select My Computer first, and then hit the Open button. So it's very cloud ready. And I'll go ahead and try and open adventureworks.com. And what I'll do, I've pre-configured this machine in a particular way here. I'm going to see an authentication prompt. Now, in the real world, assuming you've dealt with your Internet Explorer zones correctly and so on, you wouldn't see it. No, it doesn't respond to the click. It's doing something, it's kind of flickering. There you go. So I'll log in as Davis M. Oh, no, I'll do administrator, be on the safe side. This is to point out that the request management is not going to interfere with any kind of authentication process. It doesn't matter whether you're using Windows Auth, claims identity, any FBA, any of that stuff. It's completely ignorant of authentication, so it's just seamless. passes through. And in a minute, it should pop up and say, you can't open the location using this program. That's because I've killed or terminated the TCP connection at this point because I told it to not accept requests for OneNote. And of course, OneNote, it doesn't know what's happened, so it just throws up this generic error message. But that would prevent OneNote from clobbering my server and taking it out, or making it even more unhealthy. And similarly, if I attempt to open up one of those PDFs, as you know, it's pretty difficult to show, but this will open, or ask me to save it, because we don't like PDFs, right? So we force you to save them locally first. But if I go over to the SP1 machine and have a look at the ULS, a bit further down here, oh, right at the end, in fact. Oh, I'm on the wrong machine. I need to be on SPO2. And then we don't want to do Windows updates. That would be a disaster. Have you noticed how that screen pops up when you've got Windows updates open in Control Panel as well? It's not smart enough to know you're already on the screen, but anyway. Let's filter this again to request management on this machine. So this machine, SPO2, is the one with the biggest weight, right? The largest weight size. And so if I come across here, I think I might need to kick these off again. Do the other one this time. And if we're quick enough, and can flip back here quick enough, you can see here that it's mapping that request for that second PDF, so it's changing the URL effectively. It works like a reverse proxy. It maps it from contoso.com/whatever the rest of the path is to SPO1, because remember the rule for PDF says no matter what else happens, serve PDF files regardless of which site collection they're in from the routing target SPO1. And that in a nutshell is the capability request management. So I'll just flip back to the slides for a couple of minutes. I know the next guys need to get set up, so it won't be much longer, I promise. If I can find PowerPoint. Clicker doesn't work. So these are the things that we should have seen. We saw most of it. The machine pool, routing targets, rules was all done in the PowerShell script. So what I was going to do is talk through each one, but it's pretty boring stuff. You can get the scripts from my website. So it is a pretty powerful capability to improve the operational service of your farm in terms of availability, reliability, performance, capacity, scalability. You want all of those 5 things, right? There's not a SharePoint farm in the world that doesn't want those 5 things. It doesn't replace the load balancer. You need to plan out the coexistence of the load balancer with request management. Just the health-based routing, simply turning on the service instance gives you an immediate benefit for every SharePoint farm. You don't have to do anything really, it's very simple. One task. Rules planning is paramount. See these 5 things? If you screw up your rules, you'll have bad availability, bad capacity, bad performance, right? So it could hose the entire farm if you mess up the rules. So planning those out is very important. If you use regular expressions, which my script does do as an example, PowerShell, or the commandlet will actually warn us with a nice little bit of yellow saying, are you really sure you want to use regular expressions? These guys are great, but if it's a complex, badly authored regular expression, the performance penalty is significant. So watch out for those. Remember that this feature is only useful to us if we're living in the new world of logical architecture with SharePoint, which means a single web application hosting hostname site collections with no host headers. And I know that's a mouthful, but that's very important to us. You can make it work in other scenarios, but it's probably not worth the hassle and aggravation to make it work. I know what the hacks are, they're not very pleasant. Remember that the composability of PowerShell, we didn't spend much time with the scripts, but it is all in PowerShell. So if we don't have the ability to quickly make changes and understand those changes, we're not going to be able to manage the farm throughout the life cycle. We really should have a user interface for dealing with these rules and visualizing the effect of them. You know, my logical architecture diagram for them after the business requirements. We should have a tool like that that allows us to understand what's going to happen once we've implemented these rules. Again, plan the coexistence with your load balancer. Speak to the vendor of the load balancer, you know, what's their recommendations here, and make sure you understand how the interaction is going to impact operational service. Remember also to treat request management as a black box. This is not something that we can extend and plug into and add like URL translation or any other things like that that you might hear about on the internet. This is simply a black box, does its job very well. Also, don't deploy that hybrid topology. You're either in integrated mode or dedicated mode. And most of you should be in integrated mode. So with that, I know I've run over by a couple of minutes. Apologies for that. Some further links for further information. It's a 3-part series on my blog. Third part will be published in about a week. TechNet's got some stuff. You can look at that if you like. And then Steve Peshka has also got some additional scripts which do the same thing in a slightly different way. So hopefully it's been useful. Hopefully it's what you came to find out about. If you do have any questions, feel free to send those over the tweet face to SPEvo13, and we'll make sure we get to them in the Q&A on Wednesday afternoon. Thanks very much for sticking with me, even though I went late. Apologies to James and Kimmo, who are up next. Thanks very much.